Hello and welcome to Encodex Education. I'm thrilled to have you here for our very first lesson in this essential series on Linux, Git and Docker for data engineers. Since there is no previous lesson to reference, we're starting from absolute scratch. Today's focus is on Linux basics, specifically the core commands for file system navigation, permissions, and process management. By the end of this session, you'll not only understand how and why Linux was created, but also how to run common commands that are essential for any data engineering workflow. Let's get started. Before we jump into commands, let's talk about how and why Linux was originally made, and why it's still the backbone of modern computing. Linux was created by Linus Torvald in 1991, building on ideas from Unix, which was developed decades earlier. The goal was to create a free open-source operating system kernel governed by the GNU General Public License (GPL). This licensing model is crucial. It allows a software to be openly shared and modified by anyone, which sparked collaborative development across the globe. Today, major companies, including those running massive data pipelines, often rely on Linux for its stability, security, and transparency. Under the hood, Linux is composed of a kernel that manages system resources, like CPU, memory, and devices, and a set of utilities and libraries that provide an interface to that kernel. Distributions such as Ubuntu, CentOS, or Debian package the Linux kernel with user-friendly tools, making it easy to install, maintain, and update. For data engineers, Linux matters because it's where production applications often run. Whether on premises or in the cloud, understanding the file system layout, user permission, and process management is critical when you're deploying or orchestrating big data workflows. Let's assume you have some form of Linux environment ready. This could be a local machine running Linux, a virtual machine, Windows subsystem for Linux, or WSL, or even a remote server. Wherever you are, open a terminal so we can start practicing commands together. We'll create a special folder to keep all our practice materials organized. If you don't have any files or folders set up yet, let's do it together from zero. Open your terminal and type mkdir, that is short for make directory, and write Linux tutorial. This creates a new folder named the Linux tutorial in your current directory. Let's check using ls, that is list. Perfect. We have our Linux tutorial folder created. Now, let's do cd, that stands for change directory, and move to Linux tutorial. Here, we are moving into the newly created folder so we can work inside it. We are now inside the Linux tutorial directory, a clean space to explore and try out commands without affecting anything else in your system. Let's look at some fundamental commands to help you navigate the Linux file system effectively. Understanding those is essential because as a data engineer, you'll often move around directories, read logs, or locate configuration files in your environment. Let's start with pwd. Stands for print working directory. It simply outputs the full path of your current directory. Perfect. When you run pwd, it shows you exactly where you are. For instance, it might display something like home, your username, and the folder you are inside. This command is especially useful when you're deep inside the nested directories. Then let's do ls. ls lists the content of the current directory. If we run ls now, we might see nothing if the folder is empty. Perfect. If nothing is inside the Linux tutorial yet, you'll get no output or just a blank line. Let's add a file so there is something to see. We do touch and the name of the file test testfile.txt. Touch create an empty file if it doesn't already exist. Now let's see what's in our directory using ls, short for list. Perfect. You'll see textfile.txt show up. With ls, you can also use flags like ls-l, that's a lowercase for l, to show file details such as permissions, owners, and modification dates. Perfect. In Linux, permissions determine who can read, modify, or run files. They're represented by three main categories: user, U, group, G, and others, O. Each category can have read, R, write, W, and execute, X, permissions. Let's peek at how that works. Now, the output of ls-l includes something like this: your username, the date of creation, and the name of the file. The first character indicates it's a file and not a directory, the first dash. The next three characters, rw dash, are the permissions for the user. Then r dash dash are the permissions for the group, and r dash dash are the permissions for the others. This means user can read and write, but not execute. Group can only read, others can only read. If you ever need to change permission, use the chmod command by doing chmod u plus x testfile.txt. This will make testfile.txt executable by the owner only, adding the execute permission. So u implies that it's the owner plus x executable. Now let's see the new permissions. ls-l, and as you can see, now the owner can execute the file. You'll notice the user part of the permission change from something like rw dash to rwx. This can be useful when you have a script file you need to run or share with others in your team. Every file in Linux also has an owner, typically the user who created it, and a group. Sometimes in enterprise settings, you need to adjust ownership so that certain processes or team members can manage or edit files. Let's write the command sudo chown data user data group testfile.txt. Sudo gives you administrative rights if you're allowed, so you can change file ownership. chown stands for change owner. Let's say we wanted to transfer ownership of textfile.txt to a user named data user and a group data group. Now, of course, this command will only succeed if the user data user and the group data group exists on your system. Since that we haven't created the user, we get this error. So if we do now ls-l, we are still the owners of our file because we don't have data user and we don't have data group configured. In real data engineering scenarios, files often need to be owned by system users that run data processing services or scripts. Understanding how to set and verify ownership ensures your pipelines can write to or read from the correct directories. When working on large projects, you'll create, move, copy, and remove files and directories frequently. Let's illustrate some typical commands. Let's create a subdirectory by doing mkdir make directory subfolder. Let's verify it's created by using ls. Perfect. Now, move testfile.txt into subfolder by doing mv move testfile.txt into subfolder. slash. Copy text file back into Linux tutorial, but with a new name. Let's check. Okay, there is no more text file in here. So we will do cp, that stands for copy, subfolder, slash test file.txt, and we will copy it as test file copy.txt. Let's check. Perfect, we have our copy. Now let's remove the test file copy.txt by doing rm test file copy.txt. Perfect. Each command does precisely what its name implies. mv moves files, cp copies them, and rm removes them. And keep in mind, removing a file doesn't send it to a trash location by default on servers, so be careful. As a data engineer, you run processes like Python scripts or services and need to monitor or terminate them. In Linux, each process is identified by a PID, process ID. Let's discuss some of the relevant commands. PE, PS, OUX. PS is short for process status. Running PS alone might only show the current shell. Let's list more detailed info about all our processes. Perfect. Here PS displays columns like user, PED, the percentage of the CPU used, the percentage of the RAM used, and the command being run. To see an ongoing real-time view of what's using your CPU and memory, you can use top. Top, or the newer htop, if installed, is an interactive process viewer that updates in real time, showing you CPU and memory usage and more. Press Q or Ctrl Q to quit the top interface. Perfect. If you need to terminate a process for any reason, maybe your Python script got stuck, use the kill command by doing kill and the PID of the process. Let's say we have stuck a process with PID 1234. Perfect. If the process doesn't stop, we can force it with a signal like sigkill. So we do kill -9 and the PID of the process. Seeing that we have no such process, we get no such process. In real-world data pipelines, you might have Airflow workers or Spark jobs that occasionally freeze. Knowing how to gracefully or forcefully stop them is vital. Let's do a quick exercise to simulate a typical structure for storing data and logs. This helps reinforce the commands you've learned so far. Type along. mkdir data. Create a data directory. mkdir logs. Create a logs directory inside the Linux tutorial folder. Now, make a subdirectory for raw data by doing mkdir data/raw. I did an error. It should be raw. Perfect. Now we have two folders. So we will do ls cd, we enter on data, then we do ls, and then we do rmdir to remove a folder, raw. Perfect. I just corrected my error. Let's go back. Now, make a subdirectory for process data by doing mkdir data/process. Perfect. Create an empty log file for your hypothetical pipeline by doing touch logs/pipeline.log. Perfect. Now, list out the structure in a tree-like view. ls ls-r. Perfect. Now we can see each folder, what there is inside. If tree command is not installed, you can also do ls-r to recursively list, like I did. By building a small but meaningful directory structure, you'll get used to how real data engineering projects organize their assets. It's easy to make typos or accidentally remove files when working in Linux. If you ever get an error like permission denied, check if you need sudo or if your user has the right ownership. If you accidentally forget to add a slash in mvu or cp to move or copy, you might rename files in unexpected ways. Always double-check commands before pressing enter, especially destructive ones, like rm-r, which recursively deletes directories and contents. At large tech companies, you'll often log in to remote Linux servers to deploy or manage data workflows. Cloud platforms like AWS, Azure, and GCP run on Linux-based systems under the hood. Even Docker containers typically run a lightweight Linux distribution. By mastering core Linux commands, you'll be well prepared to navigate those environments, troubleshoot issues, and automate tasks. That covers the fundamental Linux commands for file system navigation, permissions, and process management. We explored how Linux came into existence, why it's open source, and demonstrated the hands-on commands to make you comfortable in a typical Linux environment. In our next lesson, we'll deep dive into shell scripting, simple automation with bash, loops, and conditionals, which will help you automate many of the commands we covered today and streamline your data engineering tasks even further. Thank you so much for joining this session on Encodex Education. If you find this lesson helpful, please like the video, share it with your friends, and subscribe for more in-depth data engineering content. I look forward to seeing you in the next lesson on shell scripting. Until then, keep practicing those Linux commands and enjoy your journey as a data engineer.